Picture this. You've been planning for months. You've watched every tutorial, saved every Pinterest board, priced out every material. And finally, you are out there swinging a hammer on your own tiny house. 3 months later, your walls won't square up. Your roof deck is bowing, and the rain found its way inside before you even hung a single door. Sound dramatic? It's not. In 2026, a mid-range DIY tiny house build. We're talking a solid 20 to 24 foot build with decent finishes. Runs between $40,000 and $65,000 in materials. Premium off-grid builds are now frequently pushing $85,000 when you factor in high-performance insulation and the new generation of smart trailers. That is real money. And industry data tells us the #1 reason DIY builds go sideways is not the budget, and it is not the tools. It's framing and roofing errors made in the first few weeks of the build. Errors you often can't see until everything else is already on top of them. I'm going to walk you through the 9 most costly, most common mistakes first-time tiny house builders make when they frame and roof their homes. The ones that lead to leaks, structural failure, code violations, and budget blowouts. And more importantly, I'm going to show you exactly how to avoid every single one of them. If you're brand new here, welcome. If you've been here before, you know I don't do fluff. No sponsored finishes, no affiliate hype. Just honest building knowledge that might save you thousands of dollars and months of heartache. Stay with me till the end, because mistake number 9 is the one almost nobody talks about, and it is the one that causes the most expensive fixes down the road. Before we dive in, if you're building a tiny house or even thinking about it, hit that subscribe button right now. Every week I put out honest, data-backed content on tiny homes, alternative housing, and DIY builds. No fluff, no gatekeeping, just the stuff that actually matters. And drop a comment below. Tell me where you are in your build. Still planning? Already framing? Or maybe you're watching because something already went wrong. I read every single comment. Alright, let's get into it. Here's the truth about framing and roofing that most build tutorials skip over. These 2 phases are the skeleton and the skin of your entire home. Everything else, insulation, plumbing, electrical, finishes, goes on top of or inside the structure you create right here. That means if you get the framing wrong, you're not just fixing walls. You are potentially ripping out finished walls, tearing off roofing material, losing insulation, and starting over. Here's how the component costs break down in 2026. This is what you're protecting when you get these phases right. DIY cost, EST 2026. Pro install, EST 2026. Lumber/steel framing, $4,500 to $7,000. $12,000 to $18,000. Sheathing/WRB, $1,800 to $3,000. $4,000 to $6,000. Standing seam metal roof, $2,500 to $4,500. $7,000 to $10,000. Fasteners/hardware, $800 to $1,200. Included. For context, a DIY build runs $40,000 to $65,000 for a standard mid-range build, but premium off-grid builds with high-performance insulation and smart trailer systems are now regularly reaching $85,000 on the DIY side. Professional builds run $70,000 to $120,000 or more. The gap between those numbers, that is what getting framing and roofing right actually protects. The tiny house market in 2026 has more good information available than ever before. But there is also more misinformation, optimistic build videos that skip the hard parts, and kits marketed as 2 weekend projects that leave out the structural decisions you actually have to make. What I'm about to share is rooted in real builder experience, real construction principles, and current 2026 data. Let's go. You built your walls. They look great lying flat on the subfloor. You stand them up, nail them in, and move on. And right there, that is where the first big mistake happens. Wall frames move. Even when you've built them perfectly on the ground, once they're vertical and exposed to slight pressure, gravity, and the natural flex of your trailer or foundation, they shift. And a wall that is even a 1/4 inch out of plumb at the bottom will compound into a nightmare by the time you reach the roof line. Your roof framing has 3 critical components: the top plate of the wall, the ridge beam at the peak, and the rafters connecting the 2. If your walls are not square to themselves and square to each other before a single rafter goes on, you'll be fighting that geometry for the rest of the build. What the right process looks like. First, check that each wall is straight across its face. Use a long level or a string line. Then verify the wall is plumb, perfectly vertical. Check each individual stud. Then confirm that all 4 walls are square to each other using the 3-4-5 triangle method, or by measuring diagonals corner to corner. Those diagonal measurements should be equal. If they're not, don't panic. Ratchet straps are your best friend here. Apply them diagonally across the frame to pull the walls into alignment. Then add your exterior sheathing to lock that position in. Once the sheathing is on, the wall is rigid and holds its shape. Only then do you start thinking about your ridge beam. This single step probably prevents more rebuild headaches than anything else on this list. Don't rush it. Not all tiny houses are built equal. And that is not just about design preference. Where your tiny house lives and how it is being built determines how it needs to be framed. If you're building on a permanent foundation, 16-inch on-center framing is the standard. It handles cumulative loads across all 4 seasons, supports heavier roof materials, and meets most code requirements without a fight. But in 2026, a significant number of DIY builders are moving to 24-inch on-center framing, and not just to save weight on a THOW. There's a thermal efficiency argument here too. The technique is called advanced framing, or OVE, optimum value engineering. Fewer studs means less wood in the wall cavity. Less wood means fewer thermal bridges, those paths where heat moves through the frame instead of staying inside where you want it. In a tight, well-insulated tiny house, that thermal performance improvement is real. The sheathing catch that most tutorials miss. Here's where first-time builders get tripped up. If you use 24-inch on-center framing, you cannot use standard 7/16-inch OSB sheathing. The wider gap between studs means the thinner sheathing will flex between attachment points, giving you wavy, visually unacceptable siding, and a structurally softer wall. In 2026, the recommended standard for 24-inch OC framing is 5/8-inch or 3/4-inch sheathing. It costs more and adds weight, but it eliminates the flex entirely and gives you a flat, solid plane to work from. And if you're modifying any standard spacing, removing jack studs, headers, or making structural changes, you need an engineer to sign off. The cost of a structural consultation is a few $100s. The cost of a failed inspection or a collapse is measured in thousands. Your roof pitch does more than define the look of your tiny house. It determines what roofing materials you can use, how well your roof sheds water, whether you get usable loft space, and how your home handles weather in your specific climate. A common beginner mistake is choosing a roof pitch based on aesthetics alone, or copying a plan without understanding the structural and material implications. What pitch actually means. Pitch is expressed as a ratio of vertical rise over 12 inches of horizontal run. A 4/12 pitch means the roof rises 4 inches for every 12 inches it travels horizontally. That is a moderate pitch, good water shedding, works with a wide range of materials, and manageable to build. A 6/12 to October 12 pitch is moderate to steep, ideal for loft space and excellent for shedding snow and heavy rain. But steeper pitches require more lumber, put more load on the frame, and are significantly harder to work on safely during construction. Below 3/12, you've just eliminated asphalt shingles and most exposed fastener metal roofing from your options. Below that threshold, you're in EPDM rubber, TPO membrane, or similar flat roof system territory. Different skills, different flashing details, and shorter average lifespans. Choose your pitch based on climate, desired materials, loft requirements, and structural capacity. Make this decision before you buy a single board. The ridge beam is the spine of your roof. It runs horizontally along the peak, and every single rafter attaches to it. If that ridge beam is even slightly out of level, you will feel in every rafter cut, every sheathing panel, and every piece of roofing material you apply. This mistake is extremely common for first-time builders because the ridge beam looks fine when you first set it. It is only when you start laying rafters that you realize one side is sitting a 1/4 inch lower than the other. How to set your ridge beam correctly. Provide temporary bracing at both ends before you commit anything permanently. Set the beam. Use the longest level you have, or a laser level if you have access to one, and shim to achieve a perfectly level surface across the full length. Once the beam is level, brace it in that position from both sides before a single rafter is attached. The beam will want to shift the moment you start applying rafter load. Bracing prevents that. Then cut one test rafter and check the fit before cutting all the others. That test rafter becomes your template. If it sits true to the top plate at the bottom and flush to the ridge at the top, you're good. Replicate it. If it doesn't fit cleanly, adjust your template before you cut 20 wrong rafters. Measure twice. Cut once. Then check the fit before you mass produce. This one habit saves hours. Here is a physics reality that catches first-time builders off guard. Rafters push outward. When you apply a load to a sloped roof, the weight of sheathing, roofing material, snow, or just gravity acting on the pitch, the rafters want to spread the walls apart. This is called outward thrust force, and if you don't account for it structurally, it will cause your walls to bow and your roof to sag over time. Collar ties, non-negotiable. Collar ties are horizontal members that connect opposing rafters near the peak. They resist the spreading force by tying the two sides together. For any build with cathedral ceilings or an open rafter design, collar ties are not optional. They hold the rafters tight to the ridge board and resist spread simultaneously. The 2026 hardware shift. Traditionally, metal hurricane ties or rafter ties with a standard connection between rafter base and top plate. They work well, but they are time-consuming to install because of the sheer number of fasteners each one requires. In 2026, many builders are moving to high-torque structural screws, products like Timber LOK or GRK, which drive faster, don't interfere with exterior trim installation, and make for a cleaner structural connection. 1 or 2 screws per location versus a dozen nailed fasteners. Just make sure whatever you use, structural screws or metal ties, is rated for uplift in your specific wind zone. That rating is not a suggestion. It is what keeps your roof on when a real storm hits. The tiny house roofing material market in 2026 gives you more choices than ever, but that abundance creates a new kind of beginner mistake. Choosing based on price or looks alone, without understanding longevity, weight, pitch requirements, or climate performance. The honest material breakdown. Asphalt shingles are the cheapest and most familiar. Easy to source, easy to install, but their lifespan is under 20 years. They require a minimum 3/12 pitch. They're prone to wind uplift, and they add 2.5 to 4.25 pounds per square foot to your structure. On a THOW where every pound affects towing dynamics, that matters. Standing seam metal roofing with concealed fasteners is widely considered the best all-around choice for tiny houses in 2026. Lifespan exceeds 35 years. Weight runs around 0.80 pounds per square foot. They work on lower pitches than shingles, resist algae and mildew, and are available in profiles that can mimic slate, shake, or traditional metal. The trade-off is upfront cost and the potential need for custom flashings on non-standard builds. Exposed fastener metal panels are a cheaper metal entry point, but the fasteners rely on sealants that fail over time, creating leak points. Life expectancy is limited to around 20 years for this reason. EPDM and TPO membranes are solid for low pitch and flat roof sections. They form a continuous waterproof membrane, are relatively lightweight, and are well suited to unconventional roof geometry. Their appearance is industrial. Installation requires specific skills. An average lifespan is around 15 years. The 2026 factor, solar shingles and BIPV weight. Building integrated photovoltaics, BPV, or what most people call solar shingles or solar tiles, have become affordable enough in 2026 to be a genuine tiny house consideration. If you are designing with a solar roof in mind, this affects your framing from day one. BIPV roofing is heavier than standing seam metal, but lighter than traditional solar panels with separate racking hardware. You need to calculate that weight into your roof framing design before you build, not as an afterthought after the frame is done. If this is on your radar, mention it to your structural engineer or run the load calculation yourself using the BIPV product's published weight per square foot. Match your material to your pitch, your climate, your weight budget, and your honest skill level. Don't let a YouTube aesthetic drive a structural material decision. This one is brief but critical, so I'm going to be blunt. Omitting roof underlayment is never a shortcut. It is a guarantee of future damage. Underlayment is the layer of protection that sits between your roof sheathing and your finished roofing material. It acts as a secondary water barrier, so that if water finds its way under a shingle, a flashing seam, or a wind-lifted panel, it hits the underlayment before it hits your wood. Industry data from 2026 is clear on this. Poor workmanship, improper flashing, ventilation errors, and skipped underlayment are the leading causes of early roof failure. Roofs that fail early do not just need new shingles. They typically need new sheathing, replaced insulation, mold remediation, and interior repairs. The cascading cost of a skipped $200 roll of underlayment is measured in thousands. Install your underlayment before any finished roofing goes on. Overlap courses correctly, typically 4 to 6 inches at horizontal seams. Around any penetration, any valley, any transition point, you add flashing integrated with the underlayment. No exceptions. The roof is the one place where extra protection costs almost nothing up front and protects everything down the road. Do not skip this layer. A roof system controls 4 things: rain, air, vapor, and thermal transfer. First-time builders almost always focus on rain, understandably. But vapor is what destroys tiny house roofs quietly and invisibly. Here's what happens when you get ventilation wrong. Warm, moist air from inside the house rises, hits the cold underside of the roof deck, and condenses. That moisture saturates your sheathing, the plywood or OSB panels forming the structural base of your roof. Over time, saturated sheathing softens, warps, and loses structural integrity. That is when you get a sagging roofline, and a sagging roofline is a structural emergency, not a cosmetic problem. In a tiny house, this is compounded by the small interior volume. Cooking, showering, and even breathing produce significant moisture relative to the square footage. Without a proper approach, that moisture has nowhere to go but up. The 2026 IRC update changes the calculation. Here is something important that has shifted in the last couple of years. The 2024 and 2025 International Residential Code updates, particularly Appendix AQ, which covers tiny houses specifically, have pushed the industry toward unvented hot roof assemblies as the standard approach for tiny houses meeting strict energy codes. Here's the practical reason. A traditional vented roof, where you run airflow from soffit to ridge vent, requires a dedicated air channel above the insulation. In a tiny house with limited rafter depth, that channel consumes 2 to 4 inches of interior headroom you probably cannot afford to lose. An unvented hot roof assembly using closed-cell spray foam eliminates that channel entirely. The spray foam bonds directly to the underside of the sheathing, acts as both insulation and vapor retarder, and removes the need for soffit-to-ridge airflow. In 2026, this is the approach most experienced tiny house builders are using. Either approach can work, vented or unvented. What fails is having no approach at all. Pick one, design it correctly, and execute it consistently. 4 unvented assemblies. I'll link the Building Science Corporation's hot roof guidelines in the description. Get familiar with those before you make your decision. I promised you at the start that mistake number 9 is the one almost nobody talks about. Here it is. There are actually 2 parts. If you're building a tiny house on wheels, the connection between your wall frame and your trailer is the most critical structural joint in the entire build. And it gets the least attention in build tutorials because it is not glamorous. When your tiny house is on the road, it endures constant vibration, lateral forces, and the occasional hard stop. If your sill plates, the bottom of your wall frames, are not properly anchored to the trailer, that movement works on every connection above it. Over time, nails back out. Framing loosens. The roof system, which is already managing its own structural forces, is now dealing with a frame that shifts beneath it. Leaks develop. Finishes crack. In worst-case scenarios, structural separation happens while the house is being towed. The correct anchoring approach. Use 5/8-inch galvanized through bolts to anchor the sill plates directly through the subfloor system and into the trailer frame. Add 2x2 by 1/4-inch steel square washers on the sill plate side for load distribution, and galvanized cut washers with lock nuts on the underside of the trailer steel. The bolts should penetrate both walls of the trailer's tube steel, meaning you need a sharp bit and a spare. Inspect this connection after the first road trip and periodically after that. The thermal bridge problem. the part most tutorials skip entirely. Here is the part that experienced builders are talking about in 2026, and that almost no beginner tutorial covers. Those steel anchor bolts create a thermal bridge straight through your floor system. In winter, the steel bolt conducts cold from the trailer into the wood sill plate. The sill plate surface drops below the dew point. Moisture condenses right at the bolt head, right inside the wood. Over years, that condensation causes rot at exactly the most critical structural joint in your build. The fix is simple and inexpensive. Use thermal brake tape or a compressible gasket between the trailer frame and the underside of your subfloor before you ever install the anchor bolts. This interrupts the thermal path, keeps the sill plate above the dew point, and protects the connection from rot. This is the mistake that causes failures you don't see until you're hundreds of miles down the highway or 5 years into the build. Take it seriously. The thermal brake costs almost nothing. The repair costs a fortune. Let's run through all 9 fast. 1. Square your walls before you touch the roof. Ratchet straps if you need them. 2. Match your stud spacing to your build type. If you go 24-inch OC with advanced framing, step up to 5/8 or 3/4 inch sheathing. No exceptions. 3. Pick your roof pitch based on climate, materials, and structure, not just looks. 4. Level your ridge beam and brace it before the first rafter goes on. Use a test rafter. 5. Install collar ties. Use rated hardware, structural screws, or metal ties for rafter-to-plate connections. Rafters push outward. Plan for it. 6. Match your roofing material to your pitch, climate, and weight limits. And if you're considering solar shingles, factor their weight into the frame design before you build. 7. Underlayment is not optional, ever. 8. Know your ventilation approach before you frame. In 2026, closed cell spray, foam hot roofs are the standard for tiny houses. Understand why before you choose. 9. Anchor your frame to the trailer with proper through bolts. Install a thermal brake tape between the trailer and the subfloor. Both matter. Here's the thing about framing and roofing a tiny house. When you get it right, you don't notice. The walls stand plumb, the roof sheds water, the structure is solid through every season. It's only when something goes wrong that you realize how much all of this matters. The people who build tiny houses that last are not always the most experienced builders. They're the ones who slowed down in the early stages, asked the right questions, and took the structural fundamentals seriously. You're watching this video. That already puts you ahead, because in 2026, the only thing that should be moving at 65 miles per hour is your trailer, not your roof shingles. If this video helped you, drop a like. It genuinely helps more people find this content, which means more builders doing it right the first time. If you're not subscribed yet, now is the time. I publish honest, research-backed tiny house and alternative housing content every single week. No fluff, no sponsor biases, just real information you can build on. And drop a comment. Tell me which of these 9 mistakes surprised you the most. I'll reply. I'll see you in the next one.